Good morning all together. I welcome you to the first session of the new Science Talk of IMO Hannover. My name is Wilfried Schäfer. I'm the General Manager of VDW, the German Machine Tool Builders Association, who is the organizer of IMO Hannover. With this Science Talk, we want to offer the IMO community a monthly input on most interesting research activities addressing technology, digitization, sustainability, new business models, and more. Today, we start with a combination out of these topics. Dr. Tobias Redlich will give us some insights into the ongoing research projects FabCity and Interfacer under the title, as you can see already, Open Source Machine Tools, the Road to Production Sovereignty and Circular Economy. Dr. Tobias Redlich has a long academia career and at present holds the title and position of the academic director of the Laboratory of Production Engineering at the Helmut Schmidt University in Hamburg. Before I hand over to Dr. Redlich, I want to motivate you to discuss these concepts after his presentation. I will pick up your questions from the chat and moderate the discussion. So, Dr. Redlich, the floor is yours.
Thank you, Mr. Schäfer. Thank you for welcoming me here and giving me the opportunity to present this topic and introducing you, or at least giving you a glimpse of these two projects, Interfacer and FabCity. Yeah, I will do that. I will present that by talking about the two recent projects that you already mentioned, and that are really the focus of my team at HSU, Helmut Schmidt University, recently. And the two projects, Interfacer and FabCity, are working together in a complementary way. So the Interfacer project is about the digital infrastructure, and the FabCity project itself is about the physical infrastructure of what we call Fab Cities. And the FabCity concept is something I will introduce you to within the next minutes. But how to start? Today, many people talk about being on a turning point. Every morning when we wake up and take a look in the news, we think we are on a turning point in our global societies and things cannot go further like they went before. So this is because of a series of events like the pandemic, war, ongoing climate change, and all that led to disrupted value chains, and we experienced that. We experienced local product shortages, and also these disruptions explicitly highlight that there is a need of resilience in areas that are highly affected by these events. And one of these areas is the production of goods. But how can we, as production engineers or people in this context, achieve resilience in this field? This is the question. And my team and me at HSU, we think that we can contribute to resilience in the regions, cities, and for the people living in them by regaining sovereignty over the knowledge, the tools, and the methods to reduce corresponding dependencies on the global supply chains. And that's why we convinced the Minister of Economy in Hamburg a few years ago to make Hamburg the first Fab City in Germany. And Fab City, this is a network of cities and regions that have pledged to work towards producing everything they consume by 2054. And to reach this goal, we should just smoothly shift from what we see on the left side, the product in, trash out, to what we see on the right side, the data in, data out scenario, from PITO to DITO. And we're starting on the left side, and because within the last decades, we lost a big deal of our production capacities and abilities in North America as well as in Europe, right? We are almost just consuming while production takes place elsewhere more and more. And we'll probably always need raw materials, and we always need global supply chains and need to organize production efficiently. But let's try to source materials and production in the regions where it's needed. This is what the DIDO paradigm means. Let's just move data and not products and waste. And how to achieve this? Well, circular economy is on the rise, and you know this term. And when it's getting more expensive to outsource production, as we experience it right now, then it becomes, of course, more beneficial to recycle, reuse, refurbish, repair, and maybe share, and especially extend the life cycle of products. And second, we need to regain the tools and ability to manufacture where the need occurs in the regions and the cities to really regain the production sovereignty. And with this Fab City project, the first project I want to introduce you to, we make Hamburg a living lab for what we call redistributed production. Together with the Fab City Hamburg Association and our Fab City project, we support existing and we will build new open production sites. So we work on an experiment on how to manufacture the things that we need within the city in Fab Labs, maker spaces, open labs, and other open production spaces. This Fab City project is funded by DTEC BW, and it will last until 2024. And within this project, we are establishing and researching a distributed production network within small workshops, as well as pop-up factories, mobile factories in different sectors such as textile, recycling, medtech, spare parts production, and so forth. And what is special, or what it's all about, open production sites such as Fab Labs or makerspaces that I mentioned already? Well, the idea is that you're able to make almost anything, that means any product, any physical product in such a space. They are open high-tech workshops with modern digital fabrication technologies, and they give low threshold access for anyone to the machines and to the workplaces that can be operated intuitively. So they're really accessible, and they are not costly thanks to open source design of the machines. And so a basic machine park in such an open production site may cost less than 50,000 euro. So while we were preparing this project or deciding on how to proceed and how to set up the open production sites, we need to go through a decision, buying the machines within these workshops commercially or making them open source. And we learned early that there is a huge community out there designing, developing, building, and modifying, or at least using open source machine tools already. And there are individuals that we are working with, different sub-communities, and even companies involved in this movement. And we started just as an experiment, building machines with this community. And we found that it worked pretty well. We took the best open source designs that we found out there, and we cooperated with some of the best developers of the open source machines. And then we started just building some of their machines together with students and other interested people in Germany, as well as in other countries, for example, in Tunisia. And we were building, for example, this huge 3D printer on the right top side here. And this just took us 1 week. And we also built the other machine you see on the bottom right side, the Laser Duo, which is a laser cutter with 2 different lasers. And it also just took us a few weeks to build this machine. And the students that were working with us, they learned just everything from the mechanics over electronics to the programming of the machines. And the participants of these building workshops, have afterwards been able to build the machines on their own. And interesting to know is that the bill of material costs for both of the machines was just below 3,000 euro. And if you would have to buy those machines commercially, you would have to pay at least 10 times more for it. And by doing this experiment, we noticed that there is a need for such machines, the open source machinery. There is a potential to spread the machines, and by doing so, enabling people to produce and manufacture wherever and whatever they need to reasonable costs. And at the same time, being able to really understand and learn how these machines work and learn how to modify the machines to make them usable for their needs. And that are just some reasons for us why we worked on the concept of the Open Lab Starter Kit, which is now one of the foci of this Fab City project, and we are developing now this Open Lab Starter Kit, which is an open source set of machines for Fab Labs and Open Labs. And we do this together with a commercial partner in this project, and we have all those goals here. First is developing the set of open source machines that is able, or that makes you being able to make almost anything. Second is to work on the documentation of those machines. Because we learned documentation is key for open source machine tools. Documentation means the bill of materials, but also guides that help you to build the machines and to operate them. And we really need to take care of this documentation process properly. Also, we want to reach the quality of commercial machines with these open source machines. And we see that the quality is increasing by a tremendous speed. And we also, at the same time, want to transfer all the knowledge behind the machines to the people using the machines, because we want to empower the people to make use of the machines. Because this is the base to creating really fully open source maker spaces and Fab Labs, and to really boost the distributed production and the circular economy, as I mentioned it. And at the end, our work here is comparable, I would say, to working on becoming the Wikipedia for machine tools. And this Open Lab Starter Kit includes a huge range of machines, large and small versions of 3D printers, laser cutters, CNC milling machines, vinyl cutters, 3D scanners, and maybe some others later on. We will have at least 8 different types of machines with 3 prototype versions, because we will have 3 different development cycles within the project, and at the end we will have at least 24 machines and prototypes. And we will have at least 15 building workshops where we test the machines as well as the documentation to understand how easy it really is now for people that participate in such building workshops to understand how the machines work. 3 of the machines have already been developed: the small laser cutter, small CNC milling machine, and a small 3D printer. And these machines do not only look nice, they are also working. They are working properly, and they are safe, and they're designed with and by the community. They are open source and not costly, and everyone will be able to learn to build and to use them. Some of the machines have been rebuilt already several times, and this works by workshops, also within the pandemic, remotely. And the workshops and the concept of workshops, together with the documentation of the machines, is key to us and to this concept of open source machinery, because we need to train the trainers that are able to help building the machines. But again, it's especially important to work on the documentation, which takes most of the capacity of such an open source machine tool development. Because the machine documentation is open source, you have different options to get one of the machines. You could first buy the whole material using the bill of materials you get from the documentation and buy it on your own and build the machine completely on your own. This will be the cheapest way to get the machine, but it will take you most of the time. The second option would be you can find a distributor that sells you the ready-to-use machine. Of course, this will be the most expensive because this is the way everything works right now with commercial machines, right? But still, this is an open source machine and you can better learn how it works because you have the full documentation. The third way, and this is what we do and what we go for right now, you will be buying a prepared kit like this one, pre-assembled, pre-manufactured, and you will build the machine on your own by using the documentation. You will operate it on your own. And you can imagine that there is it is really challenging to get such a documentation or a guide, and it will somehow look like a documentation or a guide that you know from IKEA, for example. You know, when you go to the IKEA store and buy a furniture, you get the packages and you have a really detailed guide how to build it. And the same thing is what we expect and what we are doing with those machines. So when you receive the machine and parts as prepared kit, just follow the instructions to build it. And this is how such a guide looks like. This is for the laser cutter I already showed you. And right now for the development of such a documentation, there are different people involved, for example, usability engineers and designers, and they are extracting the vector images from the CAD files and enrich them with some layout, and then are completing the whole workflow from the CAD to the documentation to operating the machine manual. But by now, this documentation is mainly handcrafted. Does not look like it, but it's handcrafted. And one of our goals in the second project, the Interfacer project, is that we want to automate the creation of such an assembly manual. This would be a big step forward in our mind to getting what I call the open source machine tool Wikipedia. Why is that? Because the development of open source machine tools, especially together or within open source communities, is not as straightforward as you may have it within a single company, a machine to a company, because you have many iterations, as we have it in the project already, and you have many people working on the project, and in parallel on the same or different problems, the same or different components of the machine. But what happens when the nice IKEA-like documentation, what happens with it when we have regular design changes? Well, the answer is just that the documentation tool itself needs to adapt to any design changes that have been made automatically. And this is what we try to achieve within this part of the project. And once this is done, you may imagine how efficient documentation may take place in future, and that by getting a better documentation, also the quality of the machines will be increasing. And yeah, as I started my presentation today with introducing the physical infrastructure, we are now talking about automated documentation, and this is something about software development. So you see how those projects are connected or complementary with each other. And I want to now talk about the second project, which is the Interfacer project. So, and the documentation I talked about is one smaller part of this Interfacer project. In general, this Interfacer project is all about the digital infrastructure for FabCities, while the FabCity project is about the physical infrastructure, right? And the goal of this Interfacer project is to build an open source digital infrastructure in the form of a federated network that is following the commons-based peer production approach. And it shall enable cities and regions to bundle, organize, and share their data and knowledge that was generated in global knowledge networks and communities of practice, as the open source communities we just saw, in order to produce physical artifacts locally in a decentralized, green, and resilient manner. Another part of this Interfacer project is the FabCity operating system. And it's the core of the Interfacer project, but I already introduced you to another sub-project of Interfacer, which is the automation, but the FabCity operating system is the core, let's say so. And the FabCity operating system helps cities and regions to set up and to run a decentralized local value creation system by matching local demand for physical artifacts. So there could be a store featuring globally sourced designs with local production capacities and matching them. So the system will also track and trace material flows by the means of a digital product passport and its functionalities. And also it may be providing resource planning capabilities with IoT applications as we all know them. FabCity OS also will be connecting hardware designers and manufacturers and will be providing economic incentives for the collaboration on a global scale based on distributed ledger technologies, this is blockchain, and a Git-based versioning system of the hardware design documentation, which is what I talked about earlier. Inventors and contributors may benefit financially anytime a physical artifact based on this documentation will be sold in a FabCity. So contributions to a design, and this is how it works, will be tracked on a design passport. And the value that is captured afterwards will be distributed among all the people that have been involved in the design process. Now, this is important because it's much harder to compensate contributions if you're not talking about a company, but a community, right? So this is why we need to have this. At the end, FabCity operating system empowers citizens to participate in the value creation and sustainably consume by giving them full access to the documentation and thus the control over the products they may buy, they may build, they may adapt, or just use or repair. So this is the FabCity operating system as one part of the digital infrastructure, and I hope that I could give you a glimpse of how the digital and physical infrastructure of the FabCities may work together and how we are covering the research and implementation in our two projects. Thank you very much for your attention.
Well, thank you very much, Mr. Redlich. Mrs. Lang, you are going to add something to it?
Yes, thank you. So I'm also a researcher and working in Mr. Redlich's team. And yeah, he already talked a lot about the loss of production capacity that is happening in Northern America and Europe at the moment, and that we basically want to gain back the ability to manufacture. And of course, one important part in all of this is the need for qualified personnel, right? Because if we don't have the people who actually use the machines or who are able to use the machines, none of this would work out. So my research part in this whole project is actually to develop an approach for an optimized and intuitive usability of those open source machine tools, but also of other machine tools. And this is something really interesting, which also could be an interesting common base with the VDB and you as machine tool developers, because we are, of course, as scientists are always interested in different views. So maybe that's something that could develop also out of this of this presentation today, that we get into a process of brainstorming or maybe talking together of how we could actually develop those optimized and intuitive usable machines in order to give access to more people actually using them. So that's maybe something you could just keep in mind, and it might happen that we contact you again, or you can contact us if this is a topic that's interesting. That just as a small input here. Thank you.
Well, thank you for these views on a very, let's say, far-looking perspective of introducing production more into cities, more into communities, combining with the living areas. Most interesting. Let's see. One question in the beginning. You mentioned the quality topic. How do you foresee on a time scale to reach the necessary quality of such open source machines? Is it only accessible with technology know-how of the people who take the know-how, like the IKEA model and build the machine, or what do you foresee?
Well, I cannot. I think the gap is already getting smaller to commercial machines. What we see here in the open source market, and I compare this to what we experience with Wikipedia too. So at the beginning of Wikipedia, we all doubted the quality of the information we got there, and it got better during the time. And this is the same here, because once we make this public, or once we have a public machine design that attracts many people to getting involved there and supporting increasing the quality, we will never have a step back, but we will always get better. So it's the same like with Wikipedia. So we need to work on tools, and we are doing that with the automated documentation to ensure the quality of the process. And once we ensure the quality of the process, we will get better product out of this process.
Okay, so let's have the scenario. We have reached this, and you have shown in this structure of production, design, and recycling, and so on. What product range to be produced on these open source machines would you foresee? Is it more for private use? Is it because you have small scale, large scale product ranges? Could you give an answer to this?
Yeah, this is not easy to give an answer to this, because we are talking on different levels now. One is the end consumer product, and of course for end consumer product it's always a problem, because we have mass production involved here, and with the machines we are talking about, they are not that automated, and they are not able right now to provide this mass production and be as efficient as a huge factory being able to have automated mass production. So they are able to produce almost anything. As I said, of course, we are not talking about cars right now. We're not talking about airplanes, but maybe every other consumer product will be a product that can come out of such an open production site. But we already show that we are even able to manufacture machine tools. So I think this is a pretty high challenge, and that we are already taking. So machine tools as a product. So this is a different level of product, right? So we are talking about maybe business to business, but what we are doing with the machine tools by developing open source machine tools, we are taking the machine tools from a business to a customer environment. This is maybe the new thing here, but at the end we will have products from every level, like business to business products as well as end consumer products. And we are involving the community, also finding products that are already now able to be manufactured in such environments. So we have, for example, an maker challenge running right now, where we invite people collecting ideas and evaluating ideas of products that may be manufactured in such an environment. And of course, people need to change, and they need to accept that if we are manufacturing on such a local scale, that a product that comes out of it will be more costly than if you would buy it from the store because it has been manufactured in Asia, for example.
But this could give an orientation to more to a focus on more customized products than on standardized products.
Exactly. So this is one big advantage. The closer you are to the manufacturing, to the plant, and the more you are involved, the better you can individualize the product. But of course, there are products that people need to, or that are more beneficial for people when they are individualized. But I think there will be always a range of products that just do not need to be customized, right?
Okay, one question concerning sustainability. You have shown this cycle of materials, but you need volume to have a good circular cycle. How do you foresee that this can be handled in such a, let's say, local environment?
Yeah, this is a good question. I have no final answer to that. We need to find out how far we can get with the raw materials and that are circulating already in our societies. But what we see now is the complete different, right, from what we want to reach. We see that waste is just going out of the country without being recycled, and we are just importing the raw materials. And this cycle is just too huge. So I think we can keep it within a smaller range within the regions to reduce logistics and at the same time saving the resources of the planet by implementing more recycling and reuse in the regions. So I don't have an answer how we can how far we can get, and we know that we do not have all the raw materials we need for all our products in our regions. That is clear, at least for now, and we need to put some research in that, how far we can get with the circular economy.
Okay, thank you. Thank you for this interesting perspective on a new setup of, let's say, local production cycles. Thank you for this. Before all the people jump out, I want to mention the upcoming speaker, which is Daniel Ranke from the IPA Fraunhofer Institute in Stuttgart. He will give us end of next month a perspective on matrix production, which means new technologies of integration into systems. So stay on board. It will be another interesting talk within the series of science talks of EMO, and I wish you all a nice day. Thank you and bye-bye.
Thank you, bye-bye.